Today it's Wednesday, April the 7th, 2021, and this is the first video for Clarios. And what we have here is a FCOG6100 board that it's going to control an SCR bridge, full weight bridge rectifier in open loop mode with a 4 to 20 milliamps that will be generated through here. For this particular video, we're going to bring in 480 volts from the wall. It's going to come here through our SCRs. We're going to rectify that output. We're going to rectify that signal, and it's going to go through our load bank, and we're going to get approximately 14-15 amps. And here's the DC output. We're going to be looking at the delay angle as a function of SIG HI and the corresponding DC output. Alright, and keeping in mind that the application for this customer is to be around 400 volts DC. So the first thing we're going to do is we're going to turn on the board, this particular case with 120 volts AC. The board has a green light, it's inhibited, but it has a phase loss because we haven't applied the 480. So when we apply the 480, the board now has cleared the phase loss. We are ready to enable the board. So go ahead and enable, Tony. Basically turn it on. And now we don't have an output. The unit is unlocked, TP3 with respect to TP5. And we don't have an output, so let's go to 4 milliamps. We can see that here. And at 4, we can always change the delay angle, but at 4, we have 0 volts DC on the output. And here again we have, according to this, about 400-500 millivolts. So this is what the output looks like, and this is what the delay angle looks with respect to this. Take a look at the difference between this leading edge to this leading edge. So we're going to slowly start increasing the SIG HI to 5, 6, 7. You want to stop at 9, Tony? Or somewhere in there. That's good. So we have 9.1 milliamps. Now we have a delay angle that has decreased. This particular delay angle, it's 85 degrees. The frequency is 60 Hertz. Have 117 volts DC output, and we have a peak to peak of about 400 volts. Something to keep in mind here is the rippage voltage, the voltage that we have between positive and negative that we're going to try to minimize. Alright, go ahead, Tony, and I want to increase SIG HI until we get approximately 400 volts DC. So because we're bringing in 480 on this particular example, it takes about, that's good, 14.29 milliamps to get 400 volts DC when our input is 473 volts AC. So the delay angle has been reduced to 52 degrees. The output is 397 volts. However, the peak, the ripple voltage, or the peak to peak, which is the ripple in this particular case, is giving us 530. In other words, we're trying to eliminate that, because if we needed to fit that into a battery bank, we wanted to either filter that or minimize that ripple voltage. So again, we could go to 20 milliamps. You really quick go to 20 milliamps. Let me just real quick, because I know that it's warming up. This particular case, we can go all the way to 600. Okay, we can come back now, and we can take a look at this. So basically, this essentially shows the open loop control of a 6100 board from 4 to 20 milliamps. So this is the end of this video.